Hello, everybody, and welcome to this month's Specify and Practice Community Group. With that, then, I want to hand it over to Dave and Lewis to get started with today's session. So, Dave and Lewis, over to you.
Thanks, Matt. This is Dave coming to you from Tuckahoe. I'm actually in the office today. Surprise, surprise. And Lewis is making me drive the presentation. I surely hope I remember how. So it's been such a long time. So, Lewis?
I'm coming to you from Hermitage, a suburb of Nashville, Tennessee. It's a little cloudy today. I think we're going to get some rain tonight. But it's pretty warm. It's pretty warm. So we wanted to talk, we thought that with the events that of the horrific and tragic fire in London, we wanted to talk about MCM wall cladding. We've been talking about doing a session on the subject anyway because there's a lot of confusion about this subject, and that the recent events kind of made it more timely, and so we're going to do that. We're not going to get too deeply into what happened in London. We do have a little bit towards the end that if we get to, and we're certainly not going to try to second guess the causes or what went on, but we will talk about that a little bit. Our focus today is to try to give you some practical ideas about how to specify the product, which is very popular. And as you can see from our title slide, we suspect, David and I, that there is actually a federal law that says that all automotive dealerships have to have a significant amount of MCM wall cladding on them.
Well, they're advertising glass and metal machines. So there you have it, glass and metal facades. So what better way to do it?
Well, let's talk about why we're calling this ACM wall cladding instead of ACM, David.
Okay, there you go. So why is it? I mean, the common term is often ACM.
Right, and for many years that was basically the only thing that was available. But over the years, manufacturers have produced the same panels with these other materials that can be on the facing. I myself have worked on at least one project that used copper-faced composite material panels. And so MCM is metal composite material, a generic description, and that's what Master Format and Master Spec both you suggest as a title for your specification sections. But if you're only doing aluminum, of course, you can call it aluminum.
Well, and the code is addressing it as MCM as well.
Yeah. So that is one of those three-letter acronyms, a TLA, that you do need to know and understand. And then there are different panel finishes that are available. Obviously, if you have stainless steel, copper, zinc, or titanium, you probably don't want to pay to paint it because those materials weather nicely and develop a patina, and the whole point is that they weather just slightly unevenly, so they really look like a natural material. But they can be polished at different levels. They don't have to be highly reflective. They can be a kind of a grain, typical granular linear panel. And then anodized. Have you ever done an anodized ACM project, David?
I have not, but there are materials out there now that are actually coil-coated anodized, which would make that a viable option as opposed to painting. Because the painted material is also coil-coated so that they get a better quality control over the entire roll and over the entire facade of the building. So it gives you much more, that coil coating process gives you a much better consistent look.
And in fact, unless you're going with one of the natural metals that we've got listed here, most people would really rather have a consistent paint color, not unlike a car's, as you pointed out earlier. So, and those paints can be either just a typical solid color, or they can be a metallic color. And most people prefer the metallic color over the a true anodized finish. And actually, the reps that I've talked to over the years have always discouraged people from specifying anodized aluminum. They make it, but they, for various reasons, discourage its use. On the painted ones, one of the things to keep in mind, it's not so much of a specification issue as a design issue, is that the metallic colors have a distinctive grain in it. Now, it's not real obvious if you look at a single panel which way the grain is running, but I guarantee you, if you take two panels and rotate them at 90 degrees to one another, you will see the difference. And so designers need to keep in mind that if their primary use is for tall vertical panels, that the horizontal panels are going to have to be narrow enough that the grain can run in the same direction. Alternatively, if your primary use is long horizontal panels, again, the vertical panels are going to have to be short enough that the grain can run in the same direction.
And this became really obvious to me many years ago, I guess, at this point, when Steve Wynn was still here in Atlantic City operating one of his casinos, and he was building out an office space and warehouse space. So they ended up using the metallic coated painted finishes. And one of the questions I had to answer to the architect actually had to go out to the site because he was complaining about the color match. We found some scrap material on the site, and all I did is held them up, oriented in different direction, and say, "Is that what you're seeing?" And he said, "Yep, absolutely." So it really becomes obvious when you can end up with the two scrap pieces like that you can play with. It just, the color difference is sometimes very, very dramatic.
Especially in the sun.
Yep.
And that brings us into the widths that are available. So again, not so much of a specification issue as it is a design issue. The widths that these things come in are very limited. So you basically have a 4-foot module or a 5-foot module as a maximum. You can get all kinds of lengths. So that means that, again, if you're orienting the grain vertically so that it's parallel to the long edge of the panels, and if you've got column covers and dividers between windows and that sort of thing on the building, then that means your fascia, or the trim, is going to be limited to those short lengths that are subject to the limitations.
Well, and one of the things to keep in mind too when you're talking about flat sheet products manufactured in given widths is the waste factor. So if you have panel sizes that don't lend themselves to getting at least two pieces out of the width of the manufactured panel, you're going to end up with an awful lot of waste. So knowing what the panel fabricators are actually providing or able to provide, and working with that, you can certainly work within that module and help eliminate a great deal of waste.
And along those lines, one of our, Ruth Trudeau from our audience, points out that there are narrower panels available for a 36-inch module from some manufacturers, not all.
Yes, there are some. So just be careful of which one that you're selecting, and working within that module, because you may not be able to get them from everybody. So you may limit your choices and the competition as well.
David, why don't you tell the folks about the options for the cores? We know about the first two. Those are pretty common.
Yeah, the polyethylene is certainly, that was the first core that was really available. And then the fire retardant core was in response to some of the building code requirements to be able to use the panels on taller buildings and non-combustible construction buildings. There's been a recent one introduced into the market. It actually has an aluminum core. It looks like a dimpled aluminum sheet and then the faces are simply laminated to that sheet. The two cores that we're most familiar with, though, the polyethylene and fire retardant, are solid cores between the two sheets. There is another panel available that uses a corrugated plastic core between the face sheets. So there are a number of varieties available, and you may want to look at the different manufacturers that are offering the different products. The aluminum core manufacturers stating that they are, at this point, the only ones available that have a truly non-combustible MCM panel.
Now, the actual makeup of the fire retardant core does have polyethylene in it, but it has mineral fibers and one thing another, and you can see it's quite a bit more dense. I suppose the polyethylene allows it is necessary so that you can bend it and for the route and return and for other forming necessities, but it does have some polyethylene in it. And interestingly enough, if you look at the manufacturer's information, they don't say too much about the difference in terms of the flame spread of these two products. They're both listed as being less than 25 flame spread when tested per ASTM E84. And we had a question from Charles Knickerbocker. What's the price steps from the the PE core to the FR core? And
to the aluminum core. So I can't answer that. I know that fire retardant is more expensive than the polyethylene, and I suspect the aluminum core it will be more expensive than both. But I don't know that for a fact.
There was some pricing information that came out in some of the news reports about the Grenfell fire issue, and they were talking about, I think it was a difference of what would in US dollars be maybe a couple of dollars a square foot. I'm not sure if it was that much, but you need to talk to your local rep about that. And Dave Metzger, going back to our grain direction, says grain direction of metallic paint finishes can be addressed in specifications by requiring that grain direction be indicated by an arrow on the strippable film or the panel backs to allow panels to be oriented in a consistent direction. And Dave is absolutely correct, as he usually is. And that's a good, I think most manufacturers would do that anyway, but that's one of those things that would be a good thing to list in your specifications.
Good point. Thank you, Dave.
Vivian Volt says, are aluminum cores considered non-combustible per code? And how about FR plastic? Oh, and then she says, ooh, thanks. So I guess we answered her question. We're always happy to oblige, Vivian. Always happy. Yeah, Eric points out the news report said that about 5,000 pounds total cost for that project. I think that's a little light, Eric, but I could be mistaken. I read so many news articles about that, researching this presentation, and then just for my own information. 5,000 pounds would be on the order of a little over $7,000, which is not a lot of money.
No, it's not.
Yeah. So, but that's what he says. That's what they were. But one of the critical things that a lot of folks don't seem to understand is the difference in the responsibilities of the cladding system that finally gets the work product that finally gets hung on the wall.
Yeah, and maybe I was going to say the easiest way to sort of think about this, in my mind, the manufacturers, in this case for MCM panels, are simply providing flat sheet. 2 sheets of aluminum stuck to a core. That's all that they're selling.
It's almost like plywood.
Exactly. So then it's up to somebody else to take that flat sheet and be able to make it into something that's usable for a building cladding system.
Although the manufacturers they do have some recommended details, and they have code compliance reports. Most of them ICC evaluation service reports that tell you how to use the product, how to form it, and install it on a building in such a way that it will in fact be code compliant. One of the newer manufacturers in the States, it's Alucoil Larson, who was originally a Spanish company but has built a plant in the U.S. recently. I believe they use ITK rather than the ICC evaluation reports. But part of it. And we're going to talk more about what's in those evaluation service reports, because it really does affect the design and the selection of which manufacturer to use even. And of course they do have installation recommendations, and in the States anyway, the recommendations are quite apart, even though it's already governed by code. The manufacturers all, or at least the ones I check, all say don't use the PE core above 40 feet in height.
So, and how many of these manufacturers, Lewis, are actually making all of the installation components, all of the backing that these panels actually get attached to?
I only know of one, and they will not do the engineering design, that they will provide the extrusions used for the local fabricator to hang it on the wall, and that's Citadel out of Indiana.
Right, and I believe you're right. The rest of them, again, going back to they're providing flat panel, relying on the fabricators to come up with the design, which is usually a delegated design, to be able to fabricate those flat panels and to be able to fabricate all the attachment accessories that are going to be required to complete the installation.
Okay. We've got a couple of comments we need to kind of get caught up with.
Only a couple? Wow. They filled the screen.
Well, no, about a half a dozen. Jay Wisnant said that he recently asked the question from one on that the cost per square foot was on the order of 30 cents premium for the fire retardant core on a large project, because of course the labor and the fabrication costs are the same. It's purely material cost. Vivian Volz has a very trenchant observation. It's my observation that lots of architects, and even to some extent the master spec specifiers, don't understand that sheet manufacturers aren't the panel fabricators. I'd like to see the specs clearly identify both. And that's exactly what we're trying to achieve here, Vivian, and you're quite right. The cladding system we need to think about primarily is hanging it on the wall. The panels that are used in the system are, in one sense, the word secondary.
Yep.
Tommy Smith asked about special inspections. We'll get to that later. And David Wu asked about NFPA 285. And again, we'll be getting to some of that a little bit later.
Coming up later, yep.
Yeah. Kelly Gray, when they're talking about code compliance for installation, isn't that more of the ASCE-7 for wind seismic loading rather than flame spread? Well, we'll get back to that. And a couple of other questions about NFPA 285 and so forth. So we will get to those. Please be patient with us. Right now we want to get this disambiguation. So the cladding system fabricators are probably going to be a local or regional installer, people who will both fabricate and install, and they're the ones who have to comply with the delegated design to meet the code requirements, the performance requirements, and also comply with manufacturer recommendations. And you may never know the names of those people that do it until you get the shop drawings coming in, because they are often not nationally known firms. There were a couple of nationally known firms that did at one time offer ACM cladding systems, and presumably they would have the deep pockets if the stuff blew off the wall. But they have since, I believe, gotten out of the business.
Oh, there are still some that remain that are more than regional. So there are some options. But, you know, if the specifications that most of us are probably working with, whether it be Master Spec or Spec Link or anything else, they're really not including any information about the fabricators for this system. So they're relying entirely on the panel manufacturers to describe them or specify those, but that only gets you, again, to the flat sheet.
And as we will see a little bit later, they really, really, really don't want to be involved in hanging the stuff on the wall. Alan Itzkowitz says that his personal master specifications, of course he's a master specifier himself and knows the secret handshakes, list both the panel manufacturers and the systems to be fabricated and installed. And yes, I think that's an important distinction that needs to be clarified in most people's specifications. Let's go to the next slide, David.
Sure.
So
this word is just way too big, Louis. I got to tell you. You know, you dug deep to find this one.
Well, you know, David, I like to indulge in airy persiflage from time to time.
Okay, so then we're going to let you explain this one, since you like to choose all these big words. You know, what happened to this? What happened to the spec language? It's supposed to be short, you know?
Oh, well, the panel manufacturers are really only going to warrant that the panels won't delaminate, and if they are coated with a PVDF fluorocarbon coating, that they have some kind of relationship with the coating manufacturer that they can warrant the coating for 20 years. But the actual responsibility, as we stated before, about the cladding system coming off the wall has to do with is on the responsibility of the cladding system fabricator, and usually they're not listed. We don't usually specify a warranty from them. So the primary warranty for the performance of the product is actually under the general contractor's general construction warranty, paragraph 3.5 of the A201.
So even if we do get a fabricator or installer warranty, probably the best that you're going to get out of them might be 2 years, because that's really about the bond limitations, especially if it's a publicly bid project.
Yes. Tommy Smith, our pal from Memphis, says, who typically retains the delegated design professional, and that's kind of up in the air. We just say that it has to, because I don't think it's appropriate to try to tell who's going to do that, but it does have to, the systems do have to be designed to meet the wind and other loading criteria.
Well, and for the most part, that's going to fall back to the fabricators, because they're the ones that are coming up with the method by which to hang these panels on the wall.
And Vivian claims that I got disambiguation from Wikipedia. Actually, I think I knew it before then, but that's okay.
You went in search. You were fishing for that word.
No.
I probably looked for it you probably were doing Google searches trying to find it.
So we drill in, and this is a language that I took from one of the leading manufacturers of MCM panels. This detail, and it's off of their recommended details. It's provided for conceptual purposes only. Actual design, panel system, fabrication, installation are not provided by, I won't identify the manufacturer, and its brand name sheets are marketed to a network of qualified fabricators, installers, which implies, by the way, you notice, David, that sort of implies that that manufacturer has somehow vetted those fabricators, that they are in fact qualified to install.
Well, at least that's some encouragement.
Who provide the installed system. The manufacturer does not make any warranties, express or implied, including merchantability and fitness for purpose.
And that last sentence is a bit troublesome, especially considering that we're talking about furnishing the product under a construction contract, and it is a contract, and we have the case where UCC, except in Mississippi, will probably apply. So UCC automatically says that because the product is furnished under a contract, there is a intent to use it for a particular purpose, and that really would exclude the manufacturer from limiting merchantability or fitness for purpose. So if this is the warranty that they're actually offering, and somebody would accept this warranty, you may have opted out of any protection under UCC.
Indeed. Our friend Scott Anderton from Birmingham, whom I got to meet earlier this year, says that SpecLink does differentiate between MCM sheet manufacturers and wall custom panel system manufacturers. He asked what some of the other master spec sources do, and I think, as you've heard, Scott, master spec does not do that very clearly. Jay Wisnett says qualified in this industry as versus roofing seldom means anything other than they pay their bills. And you're exactly right, Jay.
That can make them qualified, I suppose.
And Bob Swan from New Orleans, whom I know personally, says, why not use one of the curtain wall designers for the design of the system of panels and avoid delegated design? Well, I don't think that they would be very cooperative, because it's a different kind of product and it has different requirements. And we're going to get into some of that, because part of the issue with MCM cladding systems these days is that you got to figure out how to hold this thing up structurally, transfer the wind loads into the wall through or over 2 or 3 inches of continuous insulation. So let's go to the next slide, David.
All right. Marching on. So here's...
Oh, yes. This is yours, so you get to explain it.
Okay, so here's a summary of what has been happening in the IBC code. And I limit it to IBC, so we stop at 2000, the very first issue. It's always been under section 1407. And you see under at 2000, when IBC was first written, Section 1407 was titled ACM only, did not recognize MCM at all to address any of the other panel finishes. MCM didn't come into the code until 2003, and the major change that year was actually to change all of the wording within that section from ACM to MCM. And the other big add that year is NFPA 285. So 285 in 2003 then applied to all construction types except for type 5 construction, the ordinary wood frame. So we began to get into this condition where MCM had to comply with this full-scale fire test and be able to pass that as part of an entire exterior wall assembly, which is what 285 tests. In 2006, the code was revised and actually prohibited foam plastic core insulation because what we had... Go ahead,
point out, David, that the PE core, the polyethylene core, is not actually a foam plastic. It's a solid thermoplastic.
Correct. It's not a foam plastic. And foam plastic is governed by a different section of the code, Chapter 26, which has all kinds of restrictions just on foam plastic. But what had happened is with ACM coming into the market, there were manufacturers out there. I actually had worked with one that would take aluminum sheets and laminate it to virtually anything. One of the things was foam plastic, the other was plywood, the other was polyethylene core. So there were manufacturers in the market using foam plastic. 2006 prohibited that. So those products with the foam insulation fell out of the market. In 2009, there were we added some exceptions for fire resistance rated exterior walls, provided that the exterior wall fire rating is not compromised. So it really wasn't addressing the MCM panel per se. It was talking more about the fastenings from the MCM panel back into the wall construction to make sure that the fire rating was not compromised. It added a second test. We had ASTM E84 for surface burning. It allowed the UL test to be used also, and that was something the code did throughout. It just added the comparable test from UL. It added the requirements for UL 263, which is a standard time temperature curve to look at combustibility of the product, and it began to add the height limits. This was another code-wide change going from grade to a different term going to grade plane, which does affect how you measure the building height, and also then affects how you would measure the height of MCM panels, because now you had to measure it from grade plane instead of grade. So 2009, probably some sort of a compromise to some panel manufacturers added or allowed the use of foam plastic insulation core, as long as that core then complied with Chapter 26 of the code, which dealt with foam plastic. So that there was a significant number of changes in 2009. 2012 began to make... Yes?
Human Arian from Colorado says, as I understand, the same fire propagation requirements was in the old UBC, but was not called NFPA 285. And that's exactly right. It was a very similar test, or it may have been identical, and it had a different designation. You're quite right, Human.
Okay, is that it?
Yeah, we'll get Tommy's question in a minute.
Oh, okay. So 2012, the code actually introduced some new restrictions. It changed the test method to look at the thermal barrier between the MCM panel and the building interior. It changed it from ASTM E119 to 275, NFPA 275, which is a different kind of a test. So it changed how that thermal barrier was measured. It also added...
So that's actually, in effect, that's the gypsum sheathing or the gypsum board to protect that if the panel catches on fire, to restrict its propagation through the exterior wall into the occupied spaces.
Right. And NFPA 285 was another test that was added actually as an exception to be able to eliminate the need for a thermal barrier. So now we have a restriction on the thermal barrier in a way then to eliminate the need for a thermal barrier. The code also added two options to get additional height for MCM. Up until this 2012, there were two height limits. There was a 40-foot height limit and a 50-foot height limit. 2012, there were two new options added to be able to go to 75 feet. And there was an additional exception to the height limit by sprinklers. So if the building is fully sprinklered, the height limit need not apply. But it still had, in 2012, it added two different classes for the MCM panels, a CC1 and a CC2. CC1 is a more fire resistant panel than CC2, and those two classes then were set up in a chart, almost like the building floor area and height limit. The same sort of a concept was applied to the different categories of MCM panels. One manufacturer that I looked at actually has today a polyethylene core panel that will meet both CC1 and CC2, so that they could be used virtually in any application with where MCM is actually permitted.
Except for the catch-22.
Which is?
Well, now that the IECC, the International Energy Conservation Code, requires continuous insulation in almost all climate zones except climate zone 1, South Florida and South Texas. If you're using foam plastic for that continuous insulation, it bumps you back to the NFPA 285 testing, which may restrict. And the manufacturers that I've talked to, the three primary manufacturers, they don't have it in there. I couldn't find it in the printed literature, but their technical representatives all told me that their PE cores will not pass an NFPA 285 test.
Okay, but it will meet the requirements for CC1 and CC2. So then it's a matter of what is because 285 is a complete assembly test.
Right, and if you're using a non-combustible continuous insulation like rock wool, then you may be able to get around that.
Okay. The other thing that 2012 did is it added a maximum panel area and a maximum vertical dimension to the panels. 2015 had very few changes. There was a prohibition on the foam plastic insulation core, and that has been deleted. So now, as long as we go back to the chapter 26 for foam core insulation, I suppose it's permitted. There were very few changes in 2015. So the code has been certainly marching forward in a direction. The The one concern that I have, just because I think the code, I know they've put a lot of emphasis on sprinklers. You get a lot of exemptions because of sprinklers, and as a result of 2012, it's essentially saying that you can clad under certain circumstances, you can clad the entire building in ACM.
Jeffrey Pilas asked the question, insulated metal wall panels differ from metal composite wall panels. He asked, or do they differ only if they are used in curtain wall systems? There seems to be separate sections for each, and if you need both, where do you specify? Yes, Jeffrey, obviously many projects are going to have both types. I've certainly worked on projects like that. And they are two quite different products. Their installation is different. Their manufacturers are different. The people who make insulated metal wall panels with the integral foam plastic insulation, the metal skins are much heavier. They're much tighter, and it's just a whole different kind of product. And the manufacturer takes a lot more responsibility for the performance of those panels than does the manufacturers of MCM panels. But good question.
So I wanted to share this with everybody, mainly because I think it gives an indication of the potential hazard to some of the materials that we may be really familiar with and we know that we're using all of the time. This is if these products are burning. What kind of heat do they release as they are burning, which could impose some hazard on other materials? So it doesn't take just a quick scan of the list here on the right. You can see all of the common plastics at the top of the list. The polyethylene, polypropylene, polystyrene, we're in the range of 45 plus or minus
megajoules per kilogram.
Yes, I knew I was going to get that one wrong. Megajoules, thank you, per kilogram. And you look at the bottom of the list and you see some of the common construction materials in the wood and the cellulose, paper, straw, and such, is less than half of that heat of combustion. Polyethylene is on the same in the same range as jet fuel, the same range as gasoline. So the contribution for heat as the material is burning is really pretty tremendous.
Yeah, the fuel contribution.
So, and it really comes down to how many carbons are in the atoms making up the materials. The really heavy carbon products are the ones that are going to have the highest heat of combustion.
Scott Anderton offers the observation, now I know why you seldom see very tall auto dealerships. Stick to one story and it's hard to go wrong. Okay. Well, according to the ESR reports, the Evaluation Services reports done by the ICC Evaluation Services, and incidentally, we did a session a couple years back on that subject, and we had someone from the ICC ES, a guest speaker, who helped us guide through that, how to use those reports and how to read them and how to find them and so forth. And that's the recording is on YouTube should you want to look that up. But anyway, there are certain submittals that the fabricator has to provide to the building official. And again, these are probably good to specify. So the support system design, and then and Tommy had earlier asked about special inspections, and that is a requirement. The weather tightness thing is kind of a curious thing. If you're using an open joint system, a rain screen kind of arrangement, that's, of course, not a meaningless test, or not a meaningful test. And then the designers don't necessarily have to submit to the building code, but it is very, very advisable that you have something in your permanent project file that says that wall design does in fact meet the NFPA 285 testing.
Right, and with MCM, with the plastic cores, we're talking only with the plastic cores. Because of the plastic and because of the possibility of continuous insulation, what I have discovered through our own investigation, the only foam plastic that can be used is the fire retardant treated polyiso. Otherwise, you're into the non-combustible mineral wool insulations to be able to use MCM panels.
Yes, and we'll talk about those in a little while too, because that's what was used on London on the Grenfell project. This is a chart that I made up. I compared the ESRs from the three major manufacturers, the three most widely known manufacturers of the, and that to see the difference on their requirements. You'll notice that the wind loading difference is quite a bit. Manufacturer 1 can go 76 PSF positive, but manufacturer 2 says that their panels are only good to 25. Now, I appreciate that there's probably no significant technical difference in the way these products are manufactured, but it does, if we're going to comply with the manufacturer's instructions and limitations, if you have a very tall building, this could be a significant difference. And of course, these are wind pressures, not wind speeds. So, also on the support framing, there may be some hidden costs because manufacturer 2 or 3, oops, I misprint there. That should be number 3 on the last column on your right. Requires 54.
It's just the second manufacturer too. Okay.
54 mil studs, 16 gauge as a minimum, whereas manufacturer number 1 only requires 18 gauge, and manufacturer 2 says, well, that's up to the designer of the wall studs to figure out. But there's a significant cost difference there between 43 mil studs and 54 mil studs. On the sheathing, now you notice also that all 3 of these manufacturers, these are for the PE core, require you to use 5/8 inch type X insulation in gypsum board on the interior face of the exterior wall, or if it was a masonry equivalent.
And in commercial construction, that's probably not a big deal because we're typically not mixing and matching between 1/2 and 5/8.
Not anymore. Well, or even between 5/8 regular and 5/8 type X. It's my understanding a lot of contractors just buy everything type X because it doesn't cost any more to install, and the upcharge for the materials is not significant. And may actually save them money by not having to have 2 different types on the job site.
Right.
But our manufacturer 3 lists only 1 acceptable proprietary product for the weather-resistive barrier and for the continuous insulation, which is interesting. And they also want some very heavy-duty head and jam flashing, 16 gauge jam flashing. I mean, you can make, that's what you make door frames out of.
Yeah, exactly. some pretty hefty metal. And what they didn't talk about any of the detailing on that, did they, Lewis? Where are they trying to protect the edge of the panels? Is that
it's a little ambiguous.
Okay.
But anyway, the lesson is, or the concept is, we really do need to read these ESRs, because if you're doing a tall building, that one manufacturer may not be appropriate.
Yeah, because you get to a corner condition and that 25 PSF can be exceeded pretty quickly.
Yeah. Now, David Lawrence points out that some of these manufacturers, specifically Lugabon, does have a Dade County NOA, which, it puts you into this kind of ambiguity. On the one hand, it says that there's a certain wind load limit, and then on the other hand, they have done some testing to pass the what's that test called, David, in Miami-Dade County?
Oh, for NOA?
Impact resistance.
Yes.
Okay.
Yeah, but the one thing to remember on NOA, just like the ESR reports, they're for very specific installations, and you must comply with those NOA documents essentially exactly. It's like complying with a UL fire test. You're supposed to install them exactly as they are tested. So venturing outside of the NOA conditions would probably void that compliance report.
Yeah, we're kind of getting up on the hour, David, so let's go to the next slide.
All right.
And here's an interesting question. This is a suggested detail for a coping, and it's very typical. We see this everywhere. But the question is, does it really meet the code? Because section 1504.5 says that copings and other metal terminations for roof membranes have to be tested. And I have on more than one occasion written technical questions or addressed technical questions to all three of the major manufacturers of ACM to ask them if their coping detail has in fact been tested as required by code, and not received any answer.
Well, because they're not responsible for the fabrication and installation.
But if you follow this suggested detail, you may not be satisfying the letter of the law.
Yeah, but that manufacturer's warranty said that they're only providing stuff for concept. It's up to you.
Okay. Right. Let's see. Jeffrey Pelis says MCM manufacturers and wall panel manufacturers are listed separately in SpecLink in section 074213.23. There are several that provide both. Wouldn't it be better to determine a manufacturer who could do both and do a specification for high performance coatings so that all the flashings and fabricated metals match? I have no idea how Master Spec does it. Well, they don't, Jeffrey. Yamal Moya says 1504.5 IBC applies to roof systems. MCM wall systems must be designed to meet applicable wall wind pressures. And that's true, Yamal, but the question is, does the suggested detail for the coping that is used to secure the edge of the low slope membrane roofing, does that meet the code requirements for testing? That's the question.
Yeah, to prevent blow off.
All right. So a couple of quick things here, and Tommy Smith asks, how does FM get into this fray? I really don't know if FM has some special requirements for ACM cladding. Do you, David?
I do not, but I bet they will.
Yes, after this. And this is just so horrible because, of course, It happened in the nighttime. People were trapped in their rooms. There was only one exit stair instead of two, so that was compromised. There were just everything that could go wrong did go wrong. And you can see there's some questions here that remain to be seen. We will have to find out what actually happened. Let's go to the next slide.
Okay. And one of the questions really is, what is the rationale for having reclad and added all the thermal insulation? So if it's all about energy, did they really accomplish what they were going to do? And is this a potential price that we're willing to pay to save some energy?
And as a matter of fact, there was an interesting Marxist analysis of the situation that asked those very questions that I read. That was interesting. But for the folks that don't know, or you wouldn't know, the floor slabs come over, and then there is a concrete wall that goes upward about to just below the windows. So what they did was they put 6 inches, 150 millimeters of the fire-resistant polyisocyanurate, or at least it's alleged to be the fire-resistant type, on the wall, and then the polyethylene core Renobond on top of it. So with 6 inches, that's a significant amount of insulation in terms of the insulative value. And David, since we spoke last night in terms of our preparing for this, I ran across a statement on eArchitect, a website in London, and it said that the windows were, in fact, they used to sit on the concrete, but they were moved out so that they were above the insulation.
Oh, interesting. Interesting. Okay, but as a result, it didn't take long. We had the fire, and really just shortly after the fire, we had 2 manufacturers announce almost immediately that they're discontinuing polyethylene core sales. So we may have to, if anybody is wanting to look for polyethylene core, we may be very limited in who is even able to provide it. The manufacturers that are providing it also provide fire-resistant core. And I say we have the one manufacturer, and I think I can go ahead and name them. Vitrabond is the one that offers the aluminum core that makes their panel completely non-combustible.
With that, we appreciate you all coming. Dave and Lewis, as always, thank you for your great insight and humor on today's topic with all your banter. We look forward to seeing you all in August. With that, you may now disconnect and go about your day. Thanks, everyone.